Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we are going to be doing Unit 1, Lesson 10. Our main topic is graph linear functions for a given domain or range. Remember at the top of your notes to always put your first and your last name, the period, and the date, and make sure you write everything down as we go. Your objective for today: I will graph a portion of a linear function given a specific domain or range. So instead of graphing an entire line today, we're going to be graphing just a part of a line. And those parts of a line can be called either a segment or array. So we need to talk about the difference between the two. So a segment is a portion of a line with two endpoints. So a portion of a line with two endpoints. So instead of having an entire line that extends to the right and to the left forever, you take a piece of that line and you give it some endpoints. So what I've included here by the word segment are two examples of what a segment might look like. You could have a segment with two endpoints that are included in the domain and range, and so you have a closed circle. But today we're also going to see some segments where the endpoints are not included in the domain and range. And so as you can see, I have an example here with open circles at either end of those segments. So now let's talk about array. So array is a portion of a line with one endpoint, and then it extends forever in the opposite direction of that endpoint, or in a different direction. So array is a portion of a line with one endpoint and one never-ending side. So as you can see in my examples, I've got some rays up here. I've got an endpoint that is included in the domain and range, so it's a closed circle, and it extends forever, going to like the bottom right. Then on the other side, I've got a ray that has an endpoint that's an open circle, so that point is not included in the domain and range, and it extends forever towards the bottom. So that's the difference between a segment and array. A segment has two endpoints, an array only has one. So let's go ahead and talk about some graphs where we only see a portion of the line graphed. So in example 1, right below the word segment, actually, our first example, I have a portion of a line that's been graphed that has two endpoints. I've got an endpoint here and here. They're both closed circles, and the line extends between those 2 points. So this line does not have arrows on either end. It does not extend forever towards positive infinity and negative infinity. It ends at these 2 points. So this point, that lower left point, is the point -4, -4. The upper right point is 4, 4. So as you can see, our highest x value, I'm going to use some different colors here. Our highest x value is at 4. Our lowest x value is at -4. And it includes all the x values in between. So for example, the x value -2, we've got a point on the line. At +2, we've got a point on the line. At 0, there's a point on the line. At 2.5, there's a point on the line. So it looks like all of the x values between 4 and -4 are included in our domain. So our domain, if I put our domain in interval notation, the least number is -4, the highest number is 4, and they're both included. We have closed circles, so we use a bracket. If I wanted to describe my domain using inequalities instead of interval notation, I would say that x has to be greater than or equal to -4 and also less than or equal to 4. So these two things mean the same thing. -4 to 4 and -4 is less than or equal to x is less than or equal to 4. All right, let's talk about our y values, our range. So for my range, it looks like the highest y value on this graph goes to 4, and the least y value goes to -4. So for my range includes all the numbers between 4 and -4 for my y values. So for example, if my y value is -1, we have a point on the graph right there. If my y value is +1, we've got a point on the graph right here. And it looks like all those y values in between are included as well. So my range is from -4 to 4. If I wanted to express it as a inequality, I would say y is greater than or equal to -4 and less than or equal to 4. So this interval notation and this inequality mean the exact same thing. Now let's talk about our end behavior. So because this graph does not extend forever in either direction, we don't actually have to describe the end behavior of this graph. So for the end behavior this time, we're just going to say not applicable, NA. If the graph does extend forever in either direction or in one direction, then we're going to describe the end behavior for that. All right, so in the second part of this example, I have an example of array, and we're going to add an arrow to the bottom right-hand corner here. So this graph has an open circle for one of its endpoints, and then it extends forever going to that bottom right-hand corner. So we have an example of a array here, array. All right, so let's talk about the domain and the range. So as you can see, the least value of our domain happens at x is -1. But because we have an open circle here, due to that open circle, x equals -1 is not included. And then as our x values increase, this line extends forever. So we know that we're headed towards -infinity for our x value, or positive infinity for our x value, sorry. So for our domain, we start at -1 and head towards positive infinity. And I use parentheses because -1 is not included. We approach it, but we never reach it, and same for infinity. So now let's go ahead and talk about the range. So for our range, it looks like this line is below this y value of 3. So because all of our y's are below that point, I know that 3 is my maximum. So the 3 is the highest or the largest number in our range. And it's not included because we have an open circle. So I'm gonna have a parenthesis. And then where are those y values headed? So after y equals 3, all the y values are below that. And they're headed in the negative infinity direction. So the least value, we always list our least value first in our range, is -infinity. So our range is -infinity to 3. All right, so we have a array here, And because we have array and it extends forever in one direction, we're going to describe the end behavior of that portion of the line. So the portion of the line that extends forever is headed in this direction. And as the line heads to that bottom right-hand portion of the graph, our x values are increasing. So as x approaches infinity, y approaches, so our y's are headed in that negative infinity direction. Our y's approach negative infinity. All right. So why don't you try a couple examples on your own now? So here's a third graph. This is also an example of a segment. You've got two endpoints. One's closed at 0, -2. The other is open. And just so you know, that open point is at 3, -0.5. So why don't you go ahead and try to tell me the domain range and the end behavior. I'll give you just a second to work on that. All right, so see if your answers match mine. For the domain, I said that x goes from 0 to 3, and 0 is included. So there is a bracket, 3 is not included, so it's a parenthesis. For the range, y, it goes from -2 to -0.5. Again, -2 is included because that closed circle, so there's a bracket. -0.5 is not included. There was an open circle at that point, so I know that there's a parenthesis. And because this is a segment, we don't really describe the end behavior because the graph doesn't really have a far right or a far left. So I just put n/a, not applicable. And let's try one more example on your own. So as you can see, we have a graph that starts at this endpoint. We have our lovely ray here, and it starts at the point 40, 10. There's an open circle at that point, and then it extends forever to the upper left-hand quadrant. So go ahead and tell me about the domain and the range and the end behavior of this ray. So let's compare answers. For the domain, I said that my x values go from -infinity to 10, and just kidding, that would be my y value. My x values go from -infinity to 10 to 40. There we go, -infinity to 40. Hey, at least I caught a mistake before I published this video and made you watch it. Then my y values start at 10 and go to positive infinity. And because we have an open circle and we have -infinity and positive infinity, all of these are parentheses because none of the numbers are included. We're just approaching them, but never actually reaching them. Then I only have to this is fun. I only have to describe one portion of the end behavior because my graph extends forever to the far left. So I just described the end behavior for that portion of the graph, which means that as x approaches -infinity, y approaches positive infinity. Thank you for your patience as I tried to explain that problem. Alrighty then. Let's move on. So now we are going to work on learning how to graph a function given a restricted domain or range. So all 4 graphs that we're going to graph for example 2 are going to be rays, which mean that we are going to have one endpoint, either open or closed, and then the graph is going to extend forever in one direction from that point. So we have to figure out what that direction is. So when you graph rays specifically, there is going to be a restriction on either the domain or range where you only have one restriction, that x has to be greater than or less than a number, or greater than or equal to or less than or equal to. So for this function, we're going to graph it, but x has to be greater than 1. For this function, we're going to graph it, but x has to be less than or equal to 4. For this one, we're going to graph it, and y has to be greater than or equal to -2. And then y will have to be less than 4 for the last one. So there's only one restriction. Y or x either have to be greater than or lesser than a specific number. So let me show you how to graph when there's only one restriction and what that's going to look like. So to graph y equals -3x plus 1 for x is greater than 1, you're going to use an endpoint, and then you're going to use the slope to find other points on the graph. So you're going to find the endpoint, and then step 2 will be use the slope. So let me show you how that's going to work. To find the endpoint, you use whatever restriction you're given. So our restriction is that x has to be greater than 1. So the endpoint will be at 1 something. So that means that we're going to use the endpoint 1 something. So we have to find what the y value of that point is. So that endpoint is at 1 and whatever that y value is. To find it, we're just going to plug in x equals 1 to the function. And the function was y equals -3x plus 1. So our function is y equals -3x plus 1. We're just going to plug in 1 for x. So -3 times 1 is -3 plus 1 is -2. So our endpoint is at the point 1, -2. So let's go ahead and plot that. So for 1, -2, our endpoint goes right there. But we need to see, is this an open or a closed circle as an endpoint? Well, x is greater than 1. Does that include 1? Can 1 be greater than itself? No, it can't. So it's definitely an open circle. 1 is not included in the solution set or in the domain, since we're talking about an x value. So right off the bat, I'm just going to remind us that less than and greater than always get an open circle, and less than or equal to, greater than or equal to, always get a closed circle. And we reviewed that when we talked about inequalities and graphing them on number lines, I think like in the second week of school. That's just a little reminder. All right, so we've graphed that endpoint. From there, we are going to use our slope to find other points on our line. However, we're going to go in the direction of our restricted domain. So we only want the values where x is greater than 1. X is greater than 1 off to the right. So where I start with my endpoint, I want to make sure I move to the right. So I'm going to use my slope. My slope is m is equal to -3. I guess we should have jotted that down here. This was in y equals mx plus b form, so we know the slope is -3. M equals -3. So that means we're going to go down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. And we see that our graph extends to the far right forever. And there we go. We've just graphed array. That's all there is to it. All right, why don't you go ahead and give this second one a shot on your own. So you're going to graph y equals -3x plus 1 for x is less than or equal to 4. So you're going to use an endpoint. I'll help you get started. You're going to use an endpoint. And you're going to use the slope. So find that endpoint. I'll give you another hint. You're going to use x equals 4. So you need to find the y value of that point. And then your slope is given to you in your equation. Go ahead and find that endpoint. Use your slopes to find other points on the graph and get to work. So I found that the endpoint would be 4, -11. Our slope is m equals -3. So this one's just a little tricky. I'm going to zoom in on my graph. Your endpoint is a closed circle because x is less than or equal to 4. So it's included. So at 4, -11, I've got my endpoint. Then because we want all the x's that are less than or equal to 4, we want all the x's that go off to the left. So even though my slope is -3, I didn't want to go down into the right because that would take me to x values that are bigger than 4. So I had to go up and to the left. I had to do the opposite because I wanted all the numbers to all the points to the left of x equals 4. So watch out for that. It's a little tricky. Okay, let's move on to another example. So now we have a restriction on the range. We have our function y equals 1/2 x minus 3, but y has to be greater than or equal to -2 this time. So again, we only have one restriction, that y has to be greater than or equal to -2. So we're gonna find one endpoint, and we're gonna use the slope. So if my equation is y is equal to 1/2 x minus 3, y is equal to 1/2 x minus 3, and I want all the y's that are greater than or equal to -2, I'm going to use y equals -2. And then my slope is 1/2, because that's what's being multiplied by x. So m equals 1/2. So for my endpoint, now I'm plugging in a value for y instead of x. So I'm going to have -2 is equal to 1/2 x minus 3. Just add 3 to both sides. 1 is equal to 1/2 x. Then multiply both sides by 2. So x is equal to 2. So our endpoint will be at 2, -2. So 2, -2. Let's see, y is greater than or equal to -2. So it's a closed circle. So we want all the y values that are greater than or equal to -2. So we want all the y values that go basically up. We want the portion of our graph that goes up, that extends towards that positive infinity portion of the graph. So I'm going to use my slope, 1/2. I'm going to go up 1 and over 2, up 1 and over 2. And I see that this line does extend and go above y of -2 on that y-axis. So this is the portion of the line that I want. Had I gone in the other direction, I would have y values that are less than -2, which I don't want in this case. All right, so go ahead and do this one on your own. The equation is y is equal to 2/3 x minus 5 for y is less than 4. So once again, you're going to find your endpoint, and then you're going to use your slope. For your endpoint, you're going to want to find the x value when y is 4 because your restriction is y is less than 4. So go ahead and find that endpoint and then use your slope to graph that function. dy equals 2/3 x minus 5. Yeah, 2/3 x minus 5. There we go. For my endpoint, I found 13.54, and I had to extend my graph just a little bit, but I graphed my endpoint with an open circle, and then I needed all the y values that are less than 4, so I wanted my graph to extend to the left instead of the right, so I had to go down 2 over 3, down 2 over 3, to be able to find that portion of the graph. All right, let's move on to graphing segments. So when I graph a segment, the difference is that I'm going to have 2 endpoints. So that means I have 2 restrictions on either the domain or range. So as you can see for this graph, x has to be greater than or equal to 0 and less than 10. So that gives us two restrictions for x. It has to be greater than or equal to 0. It also has to be less than 10. So we're going to find two endpoints for our segment. And then we're also going to use our slope still. All right. So to find those endpoints, we're going to use x equals 0 and x equals 10. So we're going to use x equals 0 and we're going to use x equals 10. So the equation was y equals negative x plus 1. Yeah. All right. So to do this, we are going to plug 0 in for x. So y is equal to negative 0 plus 1. So y is just 1. So we have the point 0, 1. Then we need to find our other endpoint, which is at 10 something. So y is equal to negative 10 plus 1. Y is equal to negative 9. So our point is 10, negative 9. And then our slope would be negative 1, since there's a negative out in front of that x. We have a negative 1 being multiplied by the x. Our slope is negative 1. So in order to do this graph, you're going to plot both of your endpoints. So we have an endpoint at 0, 1. And we have an endpoint at 10, negative 9. So 10, negative 9 would be right here. Now we need to double check whether or not those should be open circles. So according to this, x is less than or equal to 0. So 0 should be closed, but x is only less than 10. I think I said x is less than 0. X is greater than 0 here. But x has to be less than 10. It's not equal to. So this second endpoint should actually be an open circle. So I'm going to change that to an open circle. Then we're going to use our slope to fill in the points between those 2 points. So our slope is negative 1, which means from this higher point, I would just go down 1 over 1, down 1 over 1, until I get to the other point. And then I have enough points that I can actually draw in a straight line that goes through all of them. And there we go. We've graphed our segment. It's not too bad, is it? All right, why don't you go ahead and we're going to skip this example and the fourth one, the second and the fourth one. So let's do y equals 1/2 x minus 3 for y is greater than negative 1 and less than 7. So again, you have your two restrictions. I'm going to help you get set up, and then you're going to finish this problem on your own. And then you're going to use your slope to find the points in between your two endpoints. So your equation is y equals 1/2 x minus 3. And your two endpoints, this time you're going to find the x values. So your two endpoints are going to be at something negative 1 and something 7. So you've got to find those two x values. So you're going to replace this y with negative 1, solve for x, and then replace y with 7 and solve for x again. Then identify your slope, plot your two endpoints, and then use your slope to find the points in between to draw your line. Go for it. All right, so this is my work for the two endpoints. I found that my first endpoint is at 4, negative 1. The second one is at 27, which since I got such a high number for my x value for that point, I realized I'm gonna have to readjust my scale here. So I counted by 2. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 on my x-axis. And then I didn't adjust that left-hand side because we don't need it for this graph. So I put 4, negative 1 here. I put 27 here. And then for my slope, I went up 1, since I counted by 1s on my y-axis, and I went over 2 on the x-axis. So remember, it looks like I went up 1 over 1, but I'm really going over 2 because this would be 6 on the x-axis. So then I would go, Yeah, 6. So then I would go up 1 over 2, up 1 over 2 again. And we should have open circles on both of those endpoints. All right, so once you're done with this lesson, you can go ahead and start your homework. Remember, on this page, if you printed them out, we're actually skipping these 2 parts of the example just to save some time. So go ahead and get started on your homework. If you have any questions, make sure you send them to me in the chat box on Zoom. I will see you all very soon.